Okay, let's have a look at 3e from the 2014 NCEA to calculus exam. All right, it says the graph of the function g of x and the graph of its gradient function are shown below. So here's g of x, here's the gradient function. And it says find the value m, the y value, for the maximum turning point. Oh, I see. So it calls it m. Normally we use m for gradient, but this is not m gradient. This is just what's the y value at this point here. So we want to find how far up that is, basically. What is the value at this point? And they've craftily not put the units along here, because here we've got 1, 2, 3, 4. Here we've got all the units, but they haven't put them here. So we can assume, I think, that these are not necessarily. They could be 1, 2, 3, but not necessarily. So we want to make sure we get this one right. And I think the strategy is going to have to be this. We've got the gradient function here. We're going to find the equation of the gradient function. We're going to anti-differentiate to find this function here. And we're going to use some key points that we know. For example, this point here is going to be 3 along, 0 up. So we're going to have to use that point, or we could use this point here, which is 0, 0 as well. So we know a couple of points there. That's going to be useful. In the meantime, let's go and anti-differentiate this. So we've got, let's have a look and see the equation. So, well, I can just use y, and I'm just going to use the general y form, is a x minus b all squared plus c. Let's use that. So how far has this moved from the 0 position? Here's the 0 position. It's moved 1, 2 along, 1 down. So y is equal to a times x. It's moved 2 along, and it's moved 1 down. Now, what values have we got here? Well, let's use this value. This value here is quite good. We can use that one. That's 0 along and 3 up. So let's put that in here. We've got a 3 value. We've got an a. We've got a 0 minus 2 all squared minus 1. So let's go ahead and resolve that. So it's a times negative 2 squared is 4 minus 1. So I'm going to add 1 to both sides. There it is. So I've got 4a is equal to 4a is 1. And you can see that's the case anyway. It goes 1 along, 1 up, 2 along, 4 up. So 3 along must be 9 up. You could have done that without going through that rigmarole. But anyway, we've got an equation now, which is rather nice. So we've got y is equal to, and it's going to be x minus 2 all squared minus 1. So let's rewrite this out in full. So it's going to be x minus 2 minus 1. And I'm going to expand all that out. So it's going to be x times x is x squared. Minus 2 times minus 2 is positive 4. I've got negative 2 and another negative 2, which is minus 4x minus 1 on the end. So it's going to be x squared minus 4x plus 3. And that is my equation. Now, we want to find the gradient function of that. So it's going to be dy dx is going to be 2. Oh, wait. No. We want to find the integral of that. We want to find the antidifferential of that. So we're going to say, therefore, let's just call this y dash here, y dash. And now we can say, therefore, y equals, it's going to be x squared, x3 on 3, minus 4x2 on 2, plus 3x1 on 1 plus c. Tidying that up a little bit, so y is equal to 1/3 x cubed minus, this is going to be 2x squared, plus 3x plus c. Okay, now we need some more information here, but we've got some points here. We've got, this one is 3, 0. 3 along, 0 up. So let's put that in now. So I'll put sub 3, 0. There it is. So 0 is equal to, and we're going to have 1/3 cubed. Let's see here. Oh, minus 2 times 3 squared plus 3 times 3 plus c. Going off the page a little bit here. 3 cubed is 27. A third of 27 is 9, minus 3 squared is 9, 2 nines are 18, plus we've got 3 times 3 is 9, plus c. So we've got a 9. Oh, look at that. Looks like it's going to end up being 0. 9 and 9 is 0. C, so c equals 0. So the equation then we're going to have here, therefore y is equal to, and I'm going to have 1/3 x cubed minus 2x squared plus 3x. There is our equation, and we are now going to substitute in a 0 in here. Let's see. Oh, wait. We want to find, okay, when x is 0, oh no, when x is 1, we want to find when x is 1. So we're going to say when x equals 1, y is equal to, so it's going to be 1/3, 1 cubed minus 2 times 1 squared plus 3 times 1. So 1 cubed is 1, it's going to be 1/3, minus 1 squared is 1, minus 2 times 1 is 2. We're going to have plus 3 times 1 is 3. So we've got, what's that? 3 minus 2 is 1, is equal to 1 and 1/3. So therefore I'm going to put, therefore m is equal to 1 and 1/3, or you could say 4/3. And that's how I would do that. Yeah, I think that, yeah, that would be the way I do that. It's rather messy, and I've kind of gone down the side of the page in an awkward and ungainly fashion, but we kind of got to the end of that. Anyway, that's my way of thinking, and that's kind of what I would do. Hope that makes sense.